Okay, welcome back to my channel. So let's proceed. Let's continue to discuss DC motors. So this time we'll be discussing the type of motors. So actually there are many types of motors. Like for example, permanent magnet DC motor, like kanang nasa itong mga duwaan, no? Insert mo ng mga dynamo, so that is permanent magnet DC motor nga na mga magnet sa lalom ba. So dapat ay separately excited DC motors, dapat ay servo motors. Okay, sa katong mga program nga motor. So but we're going to identify the types of motor in terms of field windings. We have separately excited DC motors, we have DC shunt motors, we have DC series motors, we have compound, no? Combine na nato ang series ug ang shunt. So we have long shunt DC motors and short shunt DC motors. But this time in this video I'll be discussing the separately excited DC motor. So how or when will be the time that we call that motor excited DC motor? So when the field windings is excited by a separate DC source. This is the schematic diagram now. So our field windings is supplied by a certain source of power. So sample battery siya. Okay, so this is the schematic diagram. So VS, so simple na kayo. So VS, total na itong voltage na supply. Then IS, we have RA, AB, the back EMF. So as you have noticed here, AS is equal to IA. So wala naman siya ilain nga variable nga gigian. So AA is equal to IS. Okay? So wala gid yang kon. VS is equal to IARA plus the back EMF. Mura gid na iyang kon. Mura na iyang formula nga imong tanawon, no? So wala man suwat diri, so atong take note. Okay, so here VS, V sub S is equal to, okay, IARA equals plus the back EMF. So usually we are going to find what is the back EMF. So transpose na rin nato ang so money dayon ang formula for the back EMF. This is for example, at 110 separately excited motor runs at 1000 RPM while drawing an armature current of 50 amperes. Okay, so the armature resistance is 0.2. So what will be the speed when the motor draws an armature current of at the same supply, no? So 80 na iyang kuha. So what would be the formula that we are going to use, no? So we have 1000 RPM. So we have A, no? So nata diri 110. Okay, so it would be the solution. Okay, separately excited DC motor. Taman. Okay, so solution ani taman. Okay, so makuha na to ang back EMF. Taman. Back EMF kuha. So naman tay IA at first condition running man siya sa so 50. So makuha na to ang back EMF supplied by 120. So this is the formula that we are going to use. Equals this one. Okay, so we have VS, we have IARA. So kuha na to ang back EMF sa first condition. Okay, pila man ni 110. That is 50 times 0.2. So AB1 siya. So the answer is 110 minus 50 times 0.2. So 100. So we have 100 volts ng back EMF. Okay. AB1. What will be the AB2? So AB2 is makuha na natong AB2 now using this formula, no? Ay sorry, ako na ning i-cut. So what is the relationship between the back EMF and the speed? So that is they are directly proportional to each other, no? So I'm going to say that okay, so AB1 okay, AB2 is equal to N N1 N2. Okay, so you already have this one. We already have this one, but wala tani, no? Wala tana. So ang pangutana speed, no? So this is known. So how to get AB2? So AB2, how to solve AB2? The same supply siya, draw sa line current, no? Okay, so din ito kalimutan. Same lagi pa ng formula ni. Okay, ito yung sa pikas. Same na ang solution. Okay. 110 pero 80. So, pila naman eh. 94. So, 94 volts na ang EB2. 94. Okay. Substitute. We have 100 and EB2 is 94. N1 is 1000. So, what would be N2? N2 equals, okay, 100 over 94, 1000. $940 RPM. So, muna itong answer, no? So, this is the final answer. So, we have 940 RPM. No? So, pwede na po siya, diretso na lang. No? Diretso na siya dito, substitute. Example. Diretso na lang siya dito. No? So, para magdali ka. Ha? Sa'yo mo naman siya. Ano yun siya? Shortcut. So, we have and then kaning and then 1000. Solve na tayo ng 940. So, depende na. Depende yun sa yung pag-solve. Technique ni mo sa pag-solve ang problem. Okay. Okay, so that would be all in this video. Thank you and God bless everyone.